Hello everybody, my name is Alicia and for my backward design process I'm going to have students review Science TEAC 6.8b. My goal is to have students prove their understanding that force and motion are related to potential and kinetic energy. Potential energy is energy which is stored and kinetic energy is energy of motion. They will need to identify and describe the changes in position, direction, and speed of an object when acted upon by an unbalanced force. The way I'm going to have my students demonstrate this is by using paper airplanes that they will design, and we will go outside to race them in a flying contest. We will see how outside forces such as wind, gravity, and pressure will affect lift, drag, speed, and so on. I also want them to be able to help determine that their designs have an impact on how well they fly. Different designs are going to fly in different ways, just like real airplanes are all shaped differently. I've noticed that my students learn much better when they are doing something they enjoy. This activity is not only hands-on, but it also involves competition since they're going to be flying them against one another. This tends to make the students really pay attention to my directions, and they try very hard to outdo each other. They become very engaged, which is what I'm looking for in my lesson. They really like the activity and they soak in all the details this way. My essential question will be to determine if an object at rest stays in rest in that position until it is acted upon by an unbalanced force. I also want them to determine if an object will change position if an unbalanced force acts upon it. My final question will be to determine if an object in motion will continue at the same speed and direction until an unbalanced force acts upon it. At that time, will it change its speed and or direction in response to the unbalanced force? The students will start with discussing what we know of how a real airplane is made. We will then discuss in detail some of the ideas engineers have to think of whenever they want an airplane to stay in the air. What elements do real airplanes have to consider that they're going to come in contact with? We will then transfer those suggestions and ideas to our planes. I want my students to be able to understand the details of what they are learning and not just the concept of the overall picture. Many students tend to be able to restate the overall idea of a subject, but have no clue about the reasoning, how and why it works. There are current systems in place to examine each student's assessment of essential elements of the curriculum. One thing we do have a hard time testing for is if they are able to transfer this information in real life. According to Wiggins and Mathies' 2006 book, Understanding by Design, understanding requires more, the ability to thoughtfully and actively do the work with discernment, as well as the ability to self-assess, justify, and critique such doings. Transfer involves figuring out which knowledge and skills matters here and often adapting what we address that challenge at hand. That's on page 41. As educators, we need to make sure that students are not just learning the shelf of the information and are able to regurgitate it, but are also getting a deep understanding of what it means and how to apply it to real life situations. On page 41 of Understanding by Design, the challenge is not to plug in what we have learned from memory, but modify, adjust, and adapt an inherently general idea to the particulars of a situation. In Zelman, Daniels, and Heidi's 2012 4th edition book titled Best Practice Today's Standards for Teaching and Learning in American Schools, they state that kids want to know how the world works and how they specifically fit in it. This is a great activity to help the students answer how the world works and to pay attention to the details that describe the reasoning behind the essential questions and desired understanding. Thank you for your time.